So what about level measurement? As we said, we can either use local measurement using a level glass which is graded and can be easily read from sight. This shall be connected with the vessel through two connections as we can see here. If we want the reading to be processed by the control system or by the shutdown system or to be readable from the control room, then we shall use a level transmitter. There are various types of level transmitters, such as the differential pressure level transmitter, which measures the level in the vessel on the difference in static pressure between the top of the liquid level and the bottom of vessel. Or we can use displacement transmitters, which mainly depend on Archimedes' principle that a body immersed in a liquid will be buoyed up by a force to the weight of the liquid displaced. So the displacement transmitter considers adding a displacer body floating on the liquid surface. And based on the buoyant force, we can get the level reading. We can also see some transmitters working with a different way. For example, we have the guided wave radar or GWR transmitter, which works through a radar signal, or we can have ultrasonic transmitters working through a sound wave. These are normally mounted on the top of a tank or a vessel, and it sends a signal or a wave to the liquid surface and receive a reflection. Based on this reflection, it can determine the liquid level. There are many other types, but anyway, same as flow elements, the choice depends on many factors that were explained in previous video. So let's see more details about how the level transmitter is shown on the P&ID and the common accessories used. Depending on the type of the transmitter, we may need to install it on two nozzles, like a displacement type or a differential pressure type for a pressurized vessel. Or it can be one nozzle from the top of the vessel, such as a guided wave radar transmitter or an ultrasonic transmitter. Or if the vessel is working at atmospheric pressure, so for differential pressure transmitter, we shall only need one nozzle from the bottom, as the reference is already atmospheric pressure at the top. If we are dealing with a corrosive or viscous fluid or a fluid in training solids, it's common to add diaphragm seals on the instrument nozzles to prevent plugging. This is how a diaphragm seal is shown on the P&ID. As we can see, the level instrument is mounted on a bridle if we are having different transmitters reading different ranges, or we are having a level glass to read the level from the field and another transmitter, we can mount them all in one bridle. We don't need to open lots of nozzles in the vessel. However, when we talk about level transmitters performing a safety function, which means that they are protecting the process from getting unsafe or from getting some damage to the equipment or harm to personnel, then these level transmitters shall be mounted on separate nozzles. This is because they would depend on one bridle. If the bridle was plugged, we shall lose the actual reading for both transmitters, and hence the shutdown action couldn't be performed, which will end up with the plant unprotected. So this is a simplified drawing of a P&ID. What about the details that are shown in the typical details drawing? The details usually show isolation, vent, and drain valves to enable the maintenance of the instrument. They can also show what shall be provided as a piping and what shall be provided by the instrument supplier. These interfaces are very important in order to ensure that each one supplies what he is responsible for.